Hey guys, so in this example, we're going to solve a problem where we have two kids playing a seesaw, which is a classic problem in rotational equilibrium. And in this particular one, we have a kid all the way to the left, and we want to know how far we should place the kid on the right so that the system balances. All right, so it says here the seesaw is 4 meters long. So I'm going to write L equals 4 meters. The mass of the seesaw, I'm going to call this big M, is 50. And the seesaw has uniform mass distribution. That means that the mg of the seesaw is in the middle. And it's pivoted on a fulcrum at its middle. So the fulcrum is at the middle and the mg is at the middle as well. This means you have an mg down here and you also have a normal force pushing this thing up at the fulcrum. Okay, the two kids sit at opposite sides, so one on the left and the other on the right. The kid on the left has a mass of 30 and the kid on the right has a mass of 40. Okay, so first of all, you might imagine that if this is a perfectly symmetric system, you don't have to draw this, but if you have the bar held at the middle and then you got the 30 here and the 40 here, this will tilt this way because the heavier kid, they have the same distances, but the heavier kid has a bigger force pushing down, so it tilts. So the solution then is to move the heavier kid closer to the middle. Okay, that's what we want to figure out is how far from the fulcrum should the kid be? All right, so what we're doing here is we're looking for a situation where we have no rotation, so the sum of all torque will equal 0. And there are only two torques happening here. I have M1G at the left tip, which will cause a torque 1 over here, and then I have an M2G on the right side, somewhere in the middle, that's going to cause a torque 2. Note that the torque of mg is 0. mg does not produce a torque, and that's because mg acts on the axis of rotation. Normal also doesn't produce a torque for the same reason. They both act on the axis of rotation. Forces that are applied on the axis of rotation cause no torque. Since we want torques to cancel, we're just going to say that torque 1 has to equal torque 2. They're in opposite directions, so as long as they have the same magnitude, they will cancel. So I can write torque 1 equals torque 2. And once we expand this equation, that's where we'll be able to find our target variable. All right? So torque 1 is due to M1G, so it's M1G R1 sine of theta 1. And torque 2 is due to M2G, so it's going to be M2G R2 sine of theta 2. Just using the torque equation there. Notice the gravities cancel because I have gravity on all terms. And what I'm looking for is R2. All right, so let's plug in all the numbers and then get R2 out of the way. The first thing, however, I want to show you is that once I draw the R vectors, this is R1. R vector, remember, it's the axis, an arrow from the axis of rotation to the point where the force happens. So that's R1, and then this is R2. Notice that the mg's will make an angle of 90 degrees with the r vectors. So mg's and r's are making 90 degrees, which means both of these guys go away. So this simplifies to just this. M1 R1 equals M2 R2. And this is what you're going to have in almost all seesaw problems. So all of these seesaw problems will come down to this very basic ratio. All right, so we're looking for R2, and if I want to, I can even solve this with letters. R2 is just M1 over M2 times R1. That's an expression for the solution. Now let's plug in numbers. M1 is 30, M2 is 40, R1 is this distance here. We're in the middle, so this distance here has to be 2, right? The whole bar is 4, so the distance from the very middle to the very left end is half of the length, so it's 2. And if you divide this whole thing, you get 1.5 meters is R2. So R1 is 1.5, R2 is 1, I'm sorry, R1 is 2, sorry about that, and R2 is 1.5. And that should make sense. That is consistent with what we said in the beginning, that the heavier kid has to be closer to the axis of rotation. So it's actually a pretty simple ratio. So that's it for this one. Hope it makes sense, and let's keep going.